ਸਤਿ ਸ਼੍ਰੀ ਅਕਾਲ ਜੀ
Good morning, everyone present here, and I would like to welcome to all present here to our alumni lecture series. So this is the second lecture in this series. This to be delivered by Engineering Surinder Singh Broad, 2005 Mechanical Engineering pass out. It gives me immense pleasure to introduce our speaker who has graciously accepted our invitation today for this event. He did his master's degree in 2005 from Guru Nanak Dev Engineering College in Department of Mechanical Engineering, and thereafter he joined California State University for pursuing his master's in industrial engineering from 2007 to 2010. And thereafter he started working as a senior engineer in the mechanical group of the Parsons Group. He got the vast experience in handling various projects in the quality management related field in the oil and the pipeline industry. Today, he will be sharing his thoughts in the career options to choose in the field of oil, gas, and the hydraulics. And now I would like to hand over the session to Engineering Surinder Singh.
Thank you, Professor Rupinder, for letting me share my oil and gas journey as an engineer with our students here. I feel immensely proud in sharing my experience with the students that that I graduated from. So it's an honor. So like Professor Rupinder told you, my name is Surinder Singh Barar. A brief background of myself. I did my schooling in Sacred Heart Convent School, Ludhiana, and after that did my bachelor's in mechanical engineering, 2001-2005 branch. Worked in India for 2 years in the refractory industry near Hambana, and after that I got an opportunity to do my master's in industrial technology. So I went to Fresno, California State University in Fresno, California. So I did my master's there. After that, I worked as a production supervisor in a manufacturing company. And in 2011, actually, I joined oil and gas industry here in it's an industrial town north of LA, 2 hours north of LA, called Bakersfield, California. So I'm currently working as a senior mechanical engineer. I have more than almost 12 years experience now, going into 13, working as an engineer in oil and gas industry. So I will give you a brief introduction about the oil and gas industry, how is it working. So the major oil producing companies in California are, I'm sure you have heard about Chevron. It's a very renowned and famous name. So we have Chevron, we have Era Energy. Era Energy is a drilling subsidiary of drilling subsidiary of Shell Corporation, but recently, earlier this year, it was jointly owned by CPP Investments and IKEV. CPP Investments is a Canadian company, and IKEV is a German. So Shell sold Era Energy to these two companies. Then we have California Resource Corporation. Their names have been changing since ever. It was Vintage Petroleum first, and then it became Cal Energy now. So it's kind of splitting and merger and acquisitions happening there. Then we have smaller players: Berry Petroleum, Crimson Resources, SPR, Centennial Peak, Macpherson Oil, and then Oxy Petroleum, to name a few. There are more. So I'll give you the major type of oil and gas operations here. What we call is, there are two types. One is the upstream oil and gas industry, and one is the downstream oil and gas industry. So my experience is mainly in the upstream and midstream. So basically, from when the oil comes out from the wells, and then we refine it into crude oil. And once the crude oil is made, it goes to the refinery. So when the crude oil reaches the refineries, that is the downstream industry, where the refineries and where you have all the petroleum products like LPG, gasoline, diesel, naphtha, fuel oil, tar. So you have all kinds of products there from crude oil. But I am in the upstream industry, which is like, oil well drilling, rig operations, oil and water treatment, gas extraction, um, basically getting ready the crude oil to go into the refineries. Uh, this is kind of a very basic, I would say, understanding, if you will, of an oil and gas field. So you see, uh, this is the top soil, and then under the top soil you have various layers, and in these layers you will see these blue spots. So these blue spots are basically what we call as reservoir, which will have mainly oil and gas reserves. So this is the role of a geologist is to identify all the reservoirs, identify the type of oil and gas present, and then identifying drilling operation opportunities, its exploratory and within an existing field. Then we analyze well logs to identify the size, shape, and thickness of the reservoir, porosity, permeability, hydrocarbon saturation. So all those factors go into play when we decide how we are extracting the oil from these reservoirs. Um, Basic terms, porosity is the percentage of void space within a rock. Basically, the more the porous rock is, it has more voids in it, and more oil and gas is stored in those. The permeability is the easiness of uh, how the fluid flows through a rock. So, and then we have total porosity, effective porosities. Hydrocarbon saturation is the percentage of void space which is occupied by oil and or gas in the reservoir. And then we have original oil in place. That's another term that we frequently use. But this is all role of a reservoir engineer, geologist, and reservoir engineer. So we don't identify the fields. It's reservoir engineers and geologists that identify the field and let us know, okay, we found some oil down there in the reservoirs, and help us extract it. Um, and then we have drilling wells. Basically, there are three types. There are more, but for a basic knowledge, it's three types of wells. Sometimes what happens is, so vertical well is the reservoir is down here, and then you drill the hole from the top, and the reservoir you can uh, pump out oil and gas. The deviated is sometimes the access is not there from the reservoir directly from the top. So that's kind of a deviated. It's an expensive process. So the drilling is very expensive in this case. So you basically drill the pipes at an angle, not linearly but parabolically. It goes inside in the reservoir. Then we have the horizontal wells. Um, there are few fields where the reservoir is beneath riverbeds, beneath uh, buildings that you can't drill on top of them. So in those cases, you go vertically down, and then you drill horizontally into the bed, because you don't have access from the top. So these are the three kinds of main wells, that we use for taking out oil and gas from the reservoir. This is kind of a typical wellhead. This wellhead is basically, this is where the reservoir is, and then you have the production gas, the casing gas. So what happens is, when you're pulling the production out, it's not just production; it's liquid. It is a very thick tar-like substance. It has slug in it. It has tar in it. It has gases in it. So basically, what happens is, when you pull the oil out, it comes with its own elements associated with it, which we refine later on. So what we do is, sometimes we drill oil and gas together. In some reservoirs, there is too much excess of gas. So we design the wellhead in a way that the casing gas you separate the gas right at the wellhead. So you have two lines running into the facility, which has production going separately and casing gas going separately. So we refine both of them. So as young engineers, I know there has been a lot of boom in the IT industry, um, but oil and gas is kind of untapped, where I don't see a lot of Punjabi and Indian community participating in these. So basically, if you say oil and gas, it's kind of a vast field. So you have various engineering disciplines. So you have mechanical engineering, you have electrical engineering because you need a source of power, you need wiring, you need conduits, you need all kinds of electrical equipment because equipment is useless if it's not powered. So we do need some power. So electrical engineers play a major role. Then come the instrumentation and controls engineers. Uh, they play a major role in all the automation processes, all the PLC controls, all the control elements, flow controls, then pressure control valves, flow control valves, flow meters. So instrumentation and controls play a very important role. Then we have project engineers. The role of a project engineer is basically oversee all the engineering operations. So they play a role in project management as well as engineering. So if there are small projects, if there's only mechanical engineering involved, then you can just do, you can act as a mechanical engineer, and let's say you can act as a project engineer as well. Then you have structural engineering. We do need to support the structures. If you have tanks, vessels, big equipment, piping, we need to support them. We need to take care of the seismic factors in case of earthquake happens. We need to make sure the equipment is tied down properly. And then we have civil engineers. They play a major role. Actually, they are the forefronts. So whenever we design a facility, the civil engineer do the survey, they make sure the drainage is proper. They make sure they have containment areas, just in case there is a spill or leak or anything. So civil engineers, they do all the surveys of the soil to make sure what kind of structural equipment needs what kind of foundations. So that's there. And then you have the petroleum engineers. Petroleum engineers are the ones they play a major role in help with geologists and reservoir engineers. So it's a very specialized field dealing just with petroleum stuff. Now there are major design disciplines in oil and gas as well. So we have, one is the engineering side, the second is the design side. And with the design side, there are some other opportunities that come with it. So as a mechanical engineers, our role is mainly doing calculations, making sure the processes are right, making sure the piping sizes are right, the piping schedules are right, the materials are right. We're using carbon steel, stainless steel, we're using galvanized, you are using, tubing, whatever you use. But then we have mechanical engineers who play a major role in designing things in like CAD works. Basically, 3D design is the thing of the day now. 2D design is hardly anybody uses that. So you have 3D. There are very design softwares. Solid. You have CAD works. Um, then you have Aviva Engineering. Then you have 3D plant plant 3D. There are various other design softwares that we use. Similarly, with electrical designers as well, they have to route the conduits. They have to make sure the PLC panels are at the right spot. They have to follow the SIDs, safety and design. We have to have minimum distance from the wiring has to be minimum distance from the equipment, things like that. You have to have access. You have to make sure there are no trips and falls in the design. Same with the structural designers. They will design all the supports, if it's various kind of supports you have, pier supports that we dig in the ground. Then you have block supports that can stay above ground if the soil conditions don't permit drilling in there. Then we have civil designers that will lay out all the civil plans, all the drainage systems, all the elevations. Then we have surveyors, geologists, and um and the laboratory technicians as well. So let's talk about little about the basic oil field processes. There are These are the few basic ones. Basically, we have wherever the reservoir is, we create an off plot. We call it off plot um, field, um, which will contain oil, which will have oil cleaning plants, water cleaning plant. The thing is, if you are pulling out crude oil, most of it is waste and water. There is very less percentage of oil that is extracted. So oil cleaning is one part. Then you have to treat the water that comes along with oil. Then you have water softening processes. We need to make sure the water is cleaned and softened. Uh, by soften, I mean you sometimes you have hard water. It might have too much calcium in it, too much potassium in it. So we have to treat that. If we are trying to use the water for steam generation processes, excuse me. So that is another thing that we do the design and engineering on. Then we have the casing gas recovery. Like I told you, sometimes you have too much gas in the reservoirs, so we treat the gas, and then that gas can be used as fuel gas in the steam generation and other various processes. Then we have tank vapors and gas plants. Then we have basic stream drive processes, and we have cyclic steam. Basically, cyclic steam is basically you inject steam into the reservoir, and it's also called huffing and puffing method. So basically, you inject steam at high pressure into the reservoir and let it stay there for a few days or a couple of days, depending upon the pressure conditions and temperature conditions of the reservoir. And then by huffing and puffing method, that same process that you to inject steam, the same piping equipment, the water, the steam, the oil and gas comes out at high pressures. Then that can be collected. And then there are water injection processes. Some fields they are not they don't require any. The oil is not that viscous. So viscosity is the amount of thick the fluid is. So if the reservoir is not the oil in the reservoir is not that thick, or the viscosity is uh, not very high, then we use water injection. So what we do is you inject water into the reservoir at high pressures, and then we pull out oil and gas in that way. The type of injection wells in San Joaquin Valley and Central Coast. I'm from Bakersfield, so this part of California is called Central Valley. So basically, San Joaquin Valley is where most of the oil and gas is in California, and then you have Central Coast, which is closer to the Pacific Ocean. So, but they do have reservoirs there. So, those are the. So, what we have is depending on the geologist of the reservoir, there are a few different types of oil wells that are used to extract oil. The more popular ones are, like I already explained briefly in the previous slide. You have water injection method. Water at high pressure is injected into the wells through water injection to loosen the oil in reservoir and then extracted. Same with steam. Steam is injected into the reservoir at high pressure and temperature to loosen the oil in reservoirs. Where we use steam is basically areas where we have a lot of porosity in the reservoir. So you have if the reservoir bed is porous, so steam injection works best there. So you can inject steam, and then the steam goes into the pores and loosens the oil, and then oil gets extracted. And then we have the cyclic steam. It's a process where steam is injected in numerous cycles into the rocks that are porous in nature. The same well is used to extract the oil out. This method is also popularly known as huffing and puffing. So, as a life of an engineer, mechanical engineer, these are the basic, I would say, daily routine that we do. Pump calculation, piping calculation is a very important aspect. We have ANSI codes Then we have, depending upon um, what piping it is, you have B31.3, B31.4, B31.8, B31.1. Basically, depending upon if on the medium that you are using, if it's gas, I believe it's 31.8. If it's oil, mainly we use 31.1 and 31.4, 31.3 and 31.4, sorry. And then we have pump injection, pump identification specifications based on the application and process conditions. So we identify the pump, whether we are using centrifugal pump, whether we are using rotary pump, whether we are using, plunger pumps, whether we are using vertical turbine pumps. So depending on the application, we choose the pump conditions, and depending on the fluid that goes into the pumps, we select the materials and specifications. Do we need to use carbon steel pump for a normal application? If the application is severe, it's a lot of corrosive substances in it, then we use stainless steel. If it's too corrosive, then we go with higher alloys like chromium and nickel alloys. So the more you go up in the chain, the expensive the cost is. The other thing we do is equipment identification and specifications. We have tanks and vessels, compressors, heat exchangers, free water knockout, steam generators. So we are also involved in specifying um, all the equipment. What size of tank do we need? What kind of, is it a welded tank? Is it a bolted tank? What kind of pressure, what kind of safety equipments go on it? Relief valves, safety valves. All kinds of stuff. And then same with the vessel. We have to do, is it a coded vessel? If it's a coded vessel, then we have to follow the code section. It's called section 8. So we need to follow that part. So similarly with compressors and heat exchangers, steam generators, we need to make sure the soft water goes in. The fuel injectors are, we specifically size the fuel injectors. And then there is all, we need to coordinate with other disciplines. Mechanical, basically you deal with uh, electrical engineers, process engineers, civil, structural, you name it. We have to coordinate with them. Then we have process instrumentation diagrams. Popularly, we call them as P and IDs. So we create the P and IDs. It's kind of a schematic of the whole facility that we are designing. What kind of valve it is, what kind of specification of the piping it is, what kind of various other equipments are there. So all the information goes on the P and IDs. So we do that creation of P and IDs and as built P and ID. By as built we mean is sometimes there are old facilities that need their P and IDs to be updated. So we go in the field, we walk each and every line, each and every equipment, each and every part, and then we as build that. So we red line everything, and then we bring it back. The designers um, pick those comments on design softwares. So that's another thing. Then another important factor is piping and equipment stress analysis. So when you are dealing with high temperatures and pressures, there is thermal expansions happening, and then California is very earthquake prone. We do have very high seismic codes that we have to follow. So we make sure we use Caesar, and Caesar is a software that we use for stress analysis. So another opportunity there. Not too many stress engineers available. So that's another field you guys can explore as young engineers. Learn the softwares, learn the process. So Caesar analysis we create 3D modeling in there, and then we check for all the stresses. Then we design where we need the support. There is a pipe span that we need certain, so the pipes don't sag, the pipes don't expand, the pipes don't fall off the supports. So you have anchors and guides and all kinds of stuff. Then we have plot plan creation. So when we are starting the field, we create a plot plan. So plot plan means you lay out the equipment. Um, okay, I need the pumps on the pumps go here, the tanks go here, the vessels go here. The oil and cleaning equipment, oil cleaning plant goes here, the water cleaning goes there. So that's plot plan creation, equipment layout. They are kind of going hand in hand. Then we have piping layouts. We make sure we do on-plot and off-plot piping. On-plot piping is that's inside a facility. Off-plot piping is when you're transporting things or to and fro from one facility to the other or from the wellheads to the facility. That's called off-plot. So we design those. We redesign the layout for the piping. We make sure we have no access is blocked. We make sure there are road crossings. We don't, to for people to travel around in the field. So that's a lot of thought goes into it to do the piping layout and routing. So those kind of stuff. Then I want to talk briefly about various softwares, and I highly recommend if there are any. You have resources that you can learn all these softwares that will be that's very beneficial. For engineering, design and drafting, we use AutoCAD, CADWorks, SolidWorks, PDMS, Aviva. Those are kind of um, mostly 3D softwares. And then for process modeling and steam simulation, we use pipe phase, pipe flow, HYSYS. So what we do is the designers mainly work on the design softwares. The below three bullet points basically is what engineers mostly use day to day. So we use pipe flow. Basically, it's kind of 3D. It's kind of a simulation of the process. So we want to see uh, what is the net positive suction head of the pump. Do you have enough positive suction head upstream of the pump? So that the variable head should be more than the required, so the pumps don't cavitate. So we make sure we have that, and then we choose the pump. And so and so forth. We we check for the velocities in the pipe. Upstream velocities are slower, the downstream are higher. So we make sure the velocities are not too high on the downstream side of the pump where the pressure is high, so there is no corrosion and no equipment damage. Then HYSYS is for when you have a steam, when you have complex three phase, two phase, three phase flows, then we use HYSYS. HYSYS is like if you have water and steam and oil, you have everything going into the system. So HYSYS is another good software that helps us in simulating, various pressure, temperature conditions, and let us know what kind of piping we need, what kind of pressure drops we need. Then I talked to you about stress analysis. Caesar 2 is what we use. And for calculations, we do calculations, day in, day out. You have to do uh, pressure safety valve calculations. You have to do pressure relief valve calculations. You have to do flow meter calculations, and then a pressure drop calculations. Then there are piping sizing calculations. So all kinds of, you have to have tank sizing calculation, vessel sizing calculation. So that we use MathCAD. And I think I haven't listed here. There is another software called Design Calc. So the Design Calc helps you simulate piping vessels and tanks in 3D model, and then you can analyze and see, what kind of thickness do we need, what kind of size we need. So the piping Design Calc is another good software. Then we have other. This might be repetitive, but there are other careers in engineering and design. Um Mechanical engineer, electrical. Then we have facilities engineer. The facilities engineer is kind of a project engineer that oversees projects. So it's kind of like I'm a mechanical engineer. I work for a company, and then we report to that facilities engineer. The facilities engineer is kind of the contact in the on the other side of in on the industry, like if you have Chevron or Era or anybody. So we deal with facilities engineers. They coordinate everything with us. That's another lucrative career there. And then you have production engineers. We do have a production engineering field in our college as well. So production engineering plays a major role as well. Then we have civil and structural designers. Then we have construction managers. You oversee, once we design everything, then it goes into construction. So if you are more hands-on and want to be in the field, then construction management or construction manager is another good opportunity for you to be in the field, hands-on, dictating stuff, learning. It's a good learning process as well. If you're in the field, you learn more when you're sitting in the office. And you have process engineers, surveyors, geologists, all kinds of. And then the other thing is in oil and gas, basically we only deal with oil, but now since the industry is changing, taking a shift, um, there is a lot of demand for the gas. So, like, local gas companies. So, it's not only oil wells, there are gas wells as well. So, the gas industry is another, that play a major role because every household needs gas. So that's another good opportunity. They have big companies here, like we have PG&E, that's called Pacific Gas and Electric. And we in Southern California we have SoCal Gas. So there are other gas companies that deal with all kinds of gas generation. So yeah, I think that's about it. Do you have any questions or any concerns, anything you want me to ask? I'm more than happy to help you out. If I know the answer, I'll give it right away. If I don't know, I will find the answer for you.
So our session is open for the discussion. So if anybody having any doubt or any query, he can ask and unmute himself or herself and ask the question to our worthy speaker. Surinder Singh, what is the scope and the future in the oil and the gas industry as the world is seeking as a shift on the biofuels or on some renewable sources of the energy? What
Right.
will be the future and the scope in this field?
See, the future is the renewable sources is picking up. No doubt, there's definitely a shift in the industry, but the basic industry, the renewable industry is here to stay for a long time. I mean, the alternative sources have not been developed uh, at that point that you can be free of the oil industry in near future. So you definitely need oil. I mean, for domestic purposes, it's fine. You have a lot of electric car, you have solar coming in, which is good alternate resources. But if for the let's say for the and if you see the oil and gas industry, it does not just produce oil. It produces in the refineries, it produces Vaseline is a petroleum product. Then you have asphalt that's used for making roads. That is a oil and gas oil byproduct of oil and gas. Then you have diesel. Then you have naphtha. Then you have benzene. Then you have pentane. Then you have butane. So the if you say just petrol, yes, it's demand might slowly start decreasing, but overall oil industry, you still need, in day-to-day life, you still use all the products that the refinery is producing, as like 7 to 8 products. So this industry is about to stay, for a long time. I hope that that answers what you were asking.
Good morning, sir.
Yes, sir. Good morning.
Sir, I have a question.
Mhm.
Sir, what is the biggest challenge in this industry for the engineers to face it?
I think the biggest challenge is if you are graduating from India, the biggest challenge is the experience. Since we don't have exposure to local oil and gas industry, if we talk about, like, let's say Punjab only. So if you don't have major experience in this industry at all, but as long as your basics are strong, um, this industry has a lot to offer. The challenges is it's kind of when you start this industry, like I told you, I still remember when I first joined. Yeah, remember I told you the P and IDs that we call here, process and instrumentation diagrams. I don't know if you have. What year are you in? Hello.
Yes, sir.
So what year are you in?
Sir, I am in actually mechanical engineering.
In which year?
Sir, second,
Okay.
ongoing.
Okay. So basically, the biggest challenge is this industry is kind of very unique. we don't have much of experience in here. You learn as you go. It's like all the piping codes, all the piping standards, all the equipments. There's a big learning curve when you start the industry. I know the first day I joined oil and gas, my head department mechanical, he said, here are the P and IDs, and he said, okay, here are the P and IDs, go figure. And I had no idea what a P and ID looked like. So I learned from scratch. So that is your biggest challenge. As long as you are willing to learn, willing to, push yourself, I follow a 50, my boss told me to follow a 15-minute rule. If you are stuck on something for 15 minutes, get off your seat and start looking for answers. So uh, the other thing is, don't be shy. If you are stuck somewhere, you don't know anything. Ask for help. If you don't ask for help, your chances of learning is very minimal. So that's the biggest challenge. It's kind of a unique industry. In IT and computer, we have a lot of exposure globally, but this field is very specific. So that's what I would say the biggest challenge. It's continuous learning, continuously improvising yourself. Every day is a new challenge. That's what it is.
Srinivas sir, what are the relevant study that a student can take up after the graduation for pursuing his higher studies in the field of oil and the gas?
I think the first step you have to do is start learning the softwares. Uh, at least grab like SolidWorks. We don't really use that much. It's like component design. In oil and gas, we use CADWorks, Plant 3D, PDMS, Aviva Engineering. So if a person wants to excel in this field, if you have strong knowledge of those softwares, that's a big help. The other thing is, as a mechanical engineer or as a process engineer or as a production engineer, you need to have very strong basics of um, fluid engineering and thermal engineering. So those are basically if you are interested in this field, I think that the main focus should be there. And then for structural and civil engineering, and I don't know, we used to call them SOM and TOM, strength of material, and those are mainly for structural and civil guys. Make sure your foundation is very strong and willingness to learn. So if there is a possibility to take an extra course, I did my I never knew AutoCAD, so I took some training in AutoCAD. Um, you know, then I learned some 3D software. Then I learned, and everything I learned was on the job. Caesar analysis I learned. So it's kind of, you have to be open to learning and open to new ideas. That's what it is. So, as a young engineer, uh, be open, be flexible to learn things. Like I would I would
Could
say
you please explain the role of Internet of Things or the artificial? Yeah.
say it again. Sorry.
Surinder sir, could you please explain the role of Internet of Things, artificial intelligence in the field of oil and gas?
Um, in oil and gas, we are artificial intelligence. We are as of now we haven't. This industry is very basic industry. So artificial intelligence, we don't have. I haven't explored much there, but the major, I think one of the good fields is another field is um, automation and controls. So automation and controls is another uh, good area to explore if somebody is more inclined towards PLC design, program logic uh, designs. So PLC designs, if they are more inclined towards various automation processes, that might be another area to explore. Artificial intelligence, I don't have much exposure to that in oil and field, and
Artificial
if it
intelligence, I don't have much exposure to that, honestly. Artificial intelligence, Sir, if a student is want to have some internship in the field of the oil and gas, how he or she can prepare himself or herself?
That's a very good question, and I think that's kind of I think that will be kind of the first step to go into this industry. So here in US, people who are interested in this field, you know, in if they are already preparing for mechanical engineers or all the various listed engineering fields, um, internship plays a very important role because it helps you step foot in the industry. And chances are, if your internship is for 6 months or 1 year, if you do a good job, the same company can hire you as well. So it's I don't know how things happen in India there. I'm not too familiar with the oil and gas industry in India, but yes, if you want to go into this field, uh, I would highly recommend if you can get internship in any of the oil and gas industries, or oil and gas is different, and then just the gas industry is there too. So if you get your exposure, get your hands on any of those industries as an internship, apprentice. So that's I think that's a very good step forward going into this industry. There are companies here that you can apply for internships, and and yeah, it's good for both sides. They get an extra help, and then you get to learn things. So yeah, I would say that's highly recommended. If you're curious, just guys, don't be shy. Just ask questions. I'm here. Don't be shy. Just if it's in your mind, if your no question is too big or too small to ask. Just if it's in your mind, spit it out.
The domain. Uh, I'm audible, Sundarbin?
Yes,
Hello.
yes, you're audible.
Uh, uh, sir, so the companies overseas, like you work with the Shell, work with the Parsons engineer and some other reputed company. So
Right.
do they hire some freelancers who have a good hand on the softwares like SolidWorks, AutoCAD, Nexa, or any another simulation software?
There are companies that outsource. They freelancing is not that popular in our field, but there are companies that outsource their design work in various other countries. I know a few companies that get all their design work done from India, and and there are some other companies that get their design work some other countries, like, yeah, I think Philippines is another one. So there are companies that if but not as a freelancer, but they outsource their contract to a company that runs a bunch of designers that can work
Okay.
for them remotely.
Okay. So, could you please explain the certification required to get enrolled himself or herself in the field of oil and the gas?
There is no certification required as such. I think if you want to
Like
apply
to be
this,
job ready, to be job ready.
um, you should have, I think, for an entry level position, or for internship positions, just keep applying for the companies. And if there is anything, if there are any referrals needed, I can help as much as I can. So if there are some students interested, that we can give some recommendations. So, but the one thing I should mention is, um, as there are some certifications that we require in US we can become a licensed engineer as well. So that is called PE. I haven't done that test yet, It's in the process. But if you have professional engineering attached to your name, then you call it as, my name with PE at the end. So if you have PE, then you don't have to work for anybody. So you can basically work as an independent contractor working for various companies, and you can stamp the drawing, you can sign the document. So if you have a license, if you're a licensed engineer, I think that's kind of the ultimate goal should be for any engineer who's working in this industry.
Yeah, Surinder Bharat, thank you very much for the
Yes.
information. So what kinds of universities you have closer to where you live in Bakersfield area, which specializes in mechanical domain?
There are a lot of universities here. You have a set of California state universities. There's one in Bakersfield where I am from. Currently put in, and then I studied in Fresno, California State University. Fresno has a very good mechanical program. Uh, then there is another university called it's in San Luis Obispo. It's called it's Technical College there. Um, so that's in the Central Coast that has produced very good oil and gas engineers over the past. A few of my seniors graduated from there. It's called California Polytechnic University, San Luis Obispo. It's called Cal Poly, in short, Cal Poly San Luis Obispo. That's another good. It's very oil and gas oriented courses you have there. If you want to be a project engineer, there is an engineering degree that you can do as a general engineer. So as a general engineer, you can learn all the trades and then go into project engineer and project management as well. So Cal Poly San Luis Obispo is another good one. Then you have CSU, Northridge. It's kind of closer to LA. That's another good university. It's catered towards professional engineers, and so that's another good university. Then you have UC San Diego, UCLA. Those are another some good universities that you can enroll in. So yeah, a lot of good universities around here.
No, thank you very much, Surinder. So can you please try to just activate your webcam as well, if
Sure,
that's a possibility?
sure.
Yeah, appreciate that. Yeah, no, Cal Poly, those are great universities. So California,
Mhm.
we have California State University, CSUs for the students who are listening. So there are three main universities you can categorize. Cal Poly, that is in engineering field, one of the best, as Surinder mentioned. Then
Right.
we have the UCs, University of California, then CSUs. CSUs means California State Universities. Those are state-funded universities. And Surinder, about the pipeline or the gas field, so
Mhm.
this field is one of the biggest demographic where gas is being found. So what are the other areas in United States where the gas industry is very prominent?
Uh, Texas, California, Central Valley is one, and then there are big fields in Texas. Houston, Texas has a lot of onshore and offshore platforms in the Gulf where the oil extraction is happening in the sea and onshore. Then there is another big field that recently uh, is being developed. It's in Texas. It's Midland, Texas. So that Midland, Texas is kind of that reservoir is huge. I think it connects three states. You have part of it in Texas, part of it in New Mexico, and part of it is in I think in Colorado, I think, or somewhere there. So that's a very big development coming up over the past 5 6 years. Most of the Texas oil and gas, their main point of attention is Midland, Texas. It's a very fast-growing town, and a lot of very big new reservoir that's been found there. The three states. So Midland, Texas, then Houston. Then you have some isolated fields in Idaho and Colorado. But mainly, if you say oil and gas, it's Central Valley, California, and then Texas.
Yeah, no, to our students, we highly encourage just Google these terminologies. Where is Bakersfield? Where is Texas? What kind of oil industry is there? And while we are talking, please unmute yourself or put any question that you have in the chat that we can enter. So, Surendra, the US has its own oil, Mexico has its own oil. So, Canada, it is one of the biggest oil producing country as well. So, what
Yes.
areas in Canada they have the biggest oil basins and more opportunities for gas industry.
Yeah, I should also mention Alaska is another big oil and gas industry there. So the major industry in Alaska is it's not a part of mainland US, but it's still part of US. Not very remote and north. But if you guys like cold weather, stay there. There are companies in Alaska that you can work like 2 weeks off, 2 weeks on. Mainly, basically, you work for 2 weeks, 12 hours, 7 days straight, and then you take 2 weeks off. So that's another good opportunity there. And then in Canada, if you ask, Alberta state has a lot of oil there, especially north of Calgary. So with oil and gas, it's just not the oil and gas; it's the secondary industries as well. So you have piping industry, you have pump industry, you have all the vessels and tanks and fabricator and manufacturer. So you don't need to go into oil and gas production per se. You can pursue your career as as if you're good at sales, go into the pump sales. You have a technical background, go into equipment sale. Go into specifying equipment. Those kind of things. So it's a big field. So yeah, if Canada in Canada, Alberta state has a lot of oil and gas as well.
So, and you
The production
mentioned,
process is different, but yeah, it still has a lot of opportunities there.
right. So you mentioned, yeah, there are many fields connected. So once we get the oil extracted,
Mhm.
then refinery, that is another big concept where any engineer, irrespective of the domain, can get the job opportunities. Can you talk about certain big refineries and what's the concept of a refinery? What kinds of jobs one can get there?
Right. Refineries, basically, that's part of the downstream oil and gas. So the crude oil basically in California, we have two big Chevron refineries. One is in San Ramon, California, which is kind of northern Cal, and then we have one in El Segundo, California, which is closer to the LA airport. So they're big refineries there. So refineries is a different environment, very strict. It's a very complex industry. So if it's very constrained, uh, but oil. If you have if you want to go into a refinery, that's also a very good opportunity. If you are not if you are not a field guy, I think refinery is one thing that should be on the radar as well. They have facilities engineers there, they have controls engineers there. Then you have there are some regular maintenance supervisors there. So you can go into maintenance, you can go into supervision, you can go into you have a pump, you have operators there that these refineries and operations, they are 24/7. So you can be a PLC operator, you can be you can be the automation specialist. So there are a lot of opportunities in the downstream industry as well.
Right, no, that makes sense. And there's always a misconception that when we are studying that a mechanical engineer can only work in mechanical domain, civil should work in civil domain. So from the aspect of a developed country like in the United States, Canada, can one work in a different industry?
Oh yes, definitely. I mean, you yourself know, your background is different. You're working in a different field, but yeah, we have. It's all about interest. I have in our company, we had we have people who have civil engineering as background, and actually two of them, their discipline is civil, but they are working as mechanical engineers. And then for mechanical engineers, it's different. If you are mechanical engineer, there is nothing that you can't do that a process engineer does. So, or for example, me, our department, uh, our department is mechanical and process engineer. So we do mechanical work as well, and we do process work as well. So now, as a process engineer, mechanical is more on the physical aspect of things. If your chemistry is strong, then process engineer is one hell of a field that these students should strongly think into going. The process. If you're more inclined towards hydrocarbons, if you're more inclined towards heat treatment processes, how the fluid works, how the thermodynamics of things work. That's part of the process. So process engineering, mechanical engineering go hand in hand. Then I've seen civil engineers working as mechanical engineers. Then I have seen structural engineers working as civil. So it's all about your interest. I mean, the degree can take you so far, but it depends on your aptitude. Sometimes you do a degree, out of pressure or out of availability. That's what is available. That's I will take. But sometimes your interest, when you go into the field, you don't feel like this is what I need to do. So well, change it.
Yeah, no, Guru Nanak Dev Engineering College, it always creates the individuals who can
Right.
always across the domain, they can excel with their passion. So, Surendra, any good memory of Guru Nanak Dev Engineering College that comes to your mind?
There are a lot of them. Sitting at the tuck shop, uh, I know sometimes you would be late on the first class, so got a lot of beating from professors there, which I think we should. I regret we should be missing classes, but yeah, it's part of it's fun, and we are from the same batch, so there are a lot of memories there.
Yeah, no, so
Especially,
the main thing is we are all coming from the same background as the
right,
current students as well. So
right,
with the resilience, with hard work, with learning, we can absolutely excel in any domain we like, and we have a support system. Can you,
right.
at the end, what's your message to the students that are currently doing bachelors at Guru Nanak Dev Engineering College?
I would say take your professor seriously. Try to learn as much as you can. Uh, Take your practical exams very seriously, because in the end, you're more hands-on. You understand the dynamics of things. That helps you excel. Be a learner. Try to learn things. They just don't study to pass the exam. Study to get the knowledge. So once you have your knowledge, you can apply it anywhere. As an engineer, I think your first trait should be an aptitude of learning. So whatever field you are in, make sure your mental aptitude is such that, okay, this is new to me, okay, I can learn it, no big deal. Because over the course of 4 years, you have gone through so many courses, I think 56 different subjects. So you have developed a mental aptitude to learn things. So take your professor seriously. Give Study for knowledge, not for passing the exam. Once you have the knowledge, then there's a lot of opportunities in the real world.
Yeah, no, and in the end, I thank you, Surinder. Appreciate the knowledge you gave. And to the students and the college, yeah, you have your alumni across the globe. You have any question you need to find out something, reach out to the college. They have the resources. We all are here to help and assist
Yeah,
you.
yeah,
Yeah.
we are ready to help. Yeah, anytime.
Yeah, no, thank you very much, Surinder. And to the students and college, we will be back with another session, informative one next month. So keep tuned. Thank you. Appreciate that.
Thank you, guys. Bye.